All right, so which capital letters have symmetry? Where are symmetrical? We'll actually come back to this afterwards. But capital letters is important because of the way we write certain things. So I'm just going to write them here. We'll come back to it. These may not look like they are based on the way I draw, but that's my fault, not the letters. Don't hold it against the letter. For example, right there. That's just ugly. All right. We'll come, like I said, we'll come back to that after the notes. So a figure has symmetry if there exists a rigid motion, meaning a reflection, translation, rotation, or glide reflection, that maps the figure onto itself. This will make more sense as we go on. So there's two types of symmetry. There's line and rotational. Now, line symmetry is a figure in the plane has line symmetry if that figure can be mapped onto itself by a reflection in a line called the axis of symmetry. Whoops. All right. So, state whether the letter appears to have line symmetry. So, I'm going to use a dotted line. And if I drew a line straight down the middle like so, and folded it left to right, that shape would match up. The X, I could fold left to right, and I could fold top to bottom. The L does not have line symmetry. That was supposed to be no. K. Now, if it's a capital K where both the legs are the same size, then yes, you can fold it top to bottom. Now, if you think about it, if you drew your K like this, with the little one here and the big one here, like some people do, that would not have symmetry. And N, a lot of people want to say it has symmetry, but if you folded this side over on that side, it wouldn't line up. So if you split it right here and folded it over, you would have this side doing this, and you would have the original piece doing that, and you'd end up with a triangle shape. So it wouldn't work. So this is also a no. Now let's go back to our original letters, okay, and see where the line symmetry is. So straight down the middle, top to bottom, top to bottom, top to bottom, same thing. This one you can fold left to right or top to bottom. This one I didn't draw it well, but it would be top to bottom or left to right. The K is only top to bottom. M is left to right. Depending on how the O is drawn, you can actually rotate it, fold it anyway. But if it's more oblong like this, it would be top, bottom, left, right. So again, it's based on, if it's a complete circle, then you can draw a line anywhere. Left to right on that, left to right, left to right. Now I didn't draw it evenly. The top is smaller than the bottom, but you know what I meant to do. And this with the waggly tail, left to right. So those are all the capital letters that would work, and that's how you would do it. Now, rotational symmetry. Let's try that again. A figure in the plane has rotational symmetry if the figure can be mapped onto itself by rotation between 0 and 360, about the center of the figure, called the center of rotation. The number of times the figure maps onto itself as it rotates from 0 to 360 is called the order of symmetry. So how many times can you rotate it is the order. The magnitude, or the angle of rotation, is the smallest angle through which a figure can be rotated so it maps onto itself. So to calculate the magnitude, which is the smallest angle, you take 360 and you divide it by the order number. Okay? So let's see how this works. It's really easy. So I'm going to highlight this. Let's say this piece right here. We're going to rotate it. Since this is a regular polygon, if I rotated this to where that line was here, that's one order. And then if I rotated it a second time, and then a third time, and then a fourth time, and then a fifth time, that's not that much different, and then actually I would go a sixth time, full circle, 360 degrees. So yes, it rotates, obviously. The order is 6, and then 360 divided by 6 is 60 degrees. Now, this one right here only has an order of 1. Because, think about it this way, if I rotated this down here, then my hypotenuse would be on the wrong spot. And since they're all not all equal sides, it won't work. So the only way to do it is one time around, and that's 360 degrees. So there's only one way. You can just spin it around on itself, and that's it. Okay, this one. This is yes. And now think about it. See how this little point is down? If we rotate that 180 degrees, then the point will be up over here. And then if we rotate it back another 180 degrees, it'll be back to its original shape. So that's 2, and that's 180. 360 divided by 2. All right, star. Also, you can think about it as points. Like if I want to take this point, right, and I rotate it here, the star will look exactly the same. If I rotate it here, that's twice, 3 times, 4 times, and back to 360. So yes, it works. 5 times, and that's 360 divided by 5, which is 72. All right, this one is a yes. If I rotate it 180 degrees upside down, since it's a rectangle, 90 won't work. And then a second time, so it has an order of 2, and that's 180 degrees. 360, that's a dead spot here. That's weird. So 360 divided by 2 is 180 degrees. And last but not least, since this is all equal, if I rotate this point down here once, twice, 3 times, and back to the original, that's an order of 4. And 360 divided by 4 is 90 degrees. And that's it.